Okay, here's another example of solving a radical equation. This one's a little bit more complicated. So here we want to solve 4 plus the square root of 6 minus 5x, and then minus another x out here, equals 4. Okay, so remember we said in the previous example that the very first thing we always want to do is isolate the radical piece, or the radical term. So get it all by itself on one side, put everything else on the other side. So here we actually do have to do that step. So what do we have to do? Well, we start with 4 plus square root of 6 minus 5x minus x equals 4. Let's keep the square root part on the left side and put everything else on the right side. So if we have 4 plus the square root of 6 minus 5x, then here we have a minus x, so let's go ahead and add x to both sides. So this will be 4 and then plus x. Now let's subtract 4 from both sides, so then on the left we'll just be left with the square root of 6 minus 5x, and that's great, that's what we want. At this step anyway. Now if we subtract 4 from both sides, that cancels with this 4, so all we have left on this side is really just x. 0 plus x is just x. So now, the very next step, now that we've isolated the radical, we've got it all by itself on one side here. We square both sides, so just in the interest of being thorough and clear, we'll make this a completely separate step. So square root of 6 minus 5x squared equals x, and then squared. So if we square the square root of 6 minus 5x, then what happens is we just get 6 minus 5x, and then that equals x squared, okay? So now we have a quadratic equation. We do want to be careful. So let's go ahead and put everything on the right-hand side because I prefer to have positive coefficients on x squared terms. It might not matter to you, or you might prefer negative, which would be kind of weird, but to each their own, I guess. So anyway, let's go ahead and put the 6 and the negative 5x on the other side. So in other words, let's subtract 6 from both sides. So we get negative 5x equals x squared minus 6, and then we'll add 5x to both sides. So we're running out of room down here, so let's come up here. So negative 5x equals x squared minus 6. If we add 5x to both sides, we get 0 equals x squared plus 5x minus 6. Okay, now notice I kept this in sort of a standard quadratic form, squared term plus the term with the x plus or minus the constant term. So how can we solve this? Well, we can actually factor that, right? So we can factor that into what? Well, x squared plus 5x minus 6, that's going to be x plus 6 times x minus 1. Okay, does that work? Well, plus 6x, if we FOIL this, what happens? Well, we get x squared plus 6x plus minus 1x is going to give us 5x. And then plus 6 times negative 1 gives us negative 6, so that does work. So then 0 equals x plus 6, or 0 equals x minus 1. So then that tells us that x equals negative 6. Let's make that a little neater. X equals negative 6, or x equals positive 1. Okay, now notice here we got two solutions, so we do want to be very careful and make sure that they both work. So we have negative 6 and positive 1 to check. Now if we plug them back into the original equation, do they give us what we want? So let's see. So 4 plus the square root of 6 minus 5x minus x equals 4. What if we plug in x equals 1? What's going to happen? Well, then we get 4 plus the square root of 6 minus 5x, that's 5 times 1. And then we have minus another 1 equals 4. So let's see. Well, let's not do it like that. Let's just see what this equals. So 4 plus the square root of 6 minus 5 times 1. 5 times 1 is 5. 6 minus 5 is 1. So this is actually 4 plus the square root of 1 and then minus the other 1 out here. Square root of 1 is just 1. So this is 4 plus 1 minus 1, which is 4. So is that what we wanted? Yeah, we wanted to make sure that we got 4, and we did. Okay. So x equals 1 does work. That's great. Now let's go ahead and check the other guy, which is x equals negative 6. So we'll have to clear this to make some room to check. And let's see if we get what we want. So 4 plus the square root of 6 minus, so 5 times negative 6 now. 5 times negative 6. And then minus negative 6. So what does that equal? Well, so kind of a mess here. So 6, let's work inside the radical first. 6 minus 5 times negative 6. Well, minus 5 times negative 6, that's going to give us plus 30, right? So this is really, inside the square root here, we have 6 plus 30. So this is 4 plus the square root of 6 plus 30. And then minus negative 6 means plus 6. Okay. So 4 plus blah, blah, blah plus 6 means 10. Plus what's under here? Well, 6 plus 30 is 36. and then we have 10 plus, what's the square root of 36? It's 6. 10 plus 6 is 16. Does that equal 4? No, it does not. So x equals negative 6 actually does not work. Okay, so let me not label that with an x. So this is actually, let's label it with a sad face. So x equals negative 6 does not work. Okay, that's what we just found out here. When we plugged negative 6 back into the original equation, it did not work. Now, why is that? Well, the reason is when you solve equations by squaring them like this, it is possible that you're going to introduce what's called extraneous solutions. So it looks like it's a solution because we get that when we try to solve the equation, but if we go back to the very original equation and we plug that solution in, or we plug that number in, then it turns out it's not a solution, okay? So again, it comes from here when we squared this equation here, that doing that could potentially introduce extraneous solutions. So x equals 1 is actually the only one that works, and that is the solution to this equation here, x equals 1. That's the only number that satisfies this equation here. So that's another slightly more complicated example of solving a radical equation.